Hello everyone, my name is Isma Sara Gilani, my group partner are Tipiti and Adik Burja. Today we'll be talking about evolutionary algorithms. Evolutionary algorithms are more broadly the field of evolutionary computation and are a type of artificial intelligence that mimics Darwinian natural selection. They are typically used to provide good approximation solutions to the problem that cannot be solved easily using other techniques. Many optimization problems fall into this category. It may be too computationally intensive to find an exact solution, but sometimes a near optimal solution is sufficient. There are two pillars of evolution: exploration and exploitation. Exploration increases the population diversity by genetic operator, mutation, and recombination, whereas exploitation decreases population diversity by selection of parents and survivors. Evolutionary algorithms have few variants: genetic algorithm, evolutionary strategies, evolutionary programming, and genetic programming. Credit scoring is the best example for genetic programming, and it is represented as tree structures. Evolving checkers player is a good example for evolutionary programming, which is represented as real valued vectors. The good example for evolutionary strategies are jet nozzle experiment, and it is also represented as real valued vectors. Genetic algorithm has the best example of predictive analysis, and usually it is represented as bit of strings, and it's a fixed length vector. The general scheme of evolutionary algorithm looks like this. The algorithm evolved like organisms toward more ideal solution, and their evolution makes just like it does in the biological world. Algorithms that are better adapted to solve the problems get to breed and produce better and better generations as time goes on, while worse algorithms are effectively removed from the population. Algorithms are composed of individual genes, individual rules or code fragments, and good genes propagate over successive generations of algorithms, and non-performing genes like non-performing algorithms gets washed out. There are few components of evolutionary algorithm: representation, evaluation, population, parent selection mechanism, variation operator, and survivor selection mechanism. Evolutionary algorithm has initialization and termination procedures. The above steps are defined in the same order specified. Let's talk about representation. Representation is the definition of mapping between phenotypes and genotype. The representation of a problem for evolutionary computation is the choice of the data structures used for solution. For a difficult problem, choosing a good representation can have an enormous impact on the performance of evolutionary computation system. Genotype are a set of gene values applicable to variation, whereas phenotype we can evaluate or build based on genotypes. Objects forming possible solution within the original problem context are referred to as phenotypes. There are several types of representation: binary representation, real valued representation, integer representation, and permutation representation. Let's talk about binary representation first. They are like Boolean decision variables 0 or 1 or true or false. The best example for it is knapsack problem. Problem dealing with numbers can be represented as in the form of 0 and 1. Real valued representation problem are represented as in a continuous variable like 0.1, 0.5, 0.7 and so on. Integer representation, we do the encoding problems with solution spaces of more than 2 representation. For example, north, east, west, south For this we can take 0, 1, 2, 3 as a subset. For color encoding we can use 1, 2, 3. For permutation representation, solution space represented by order of elements. The best example for it is traveling salesman problem. Let's talk about fitness function. We also call it evaluation process, a function which takes a candidate solution as input to a problem and produces as output, which measures how fit our solution is with respect to the problem. Usually same as objective function, except in complex scenarios with multiple objectives and constraints. It must be as fast as this affects the time taken by genetic algorithm. So fitness approximation must be done for complex problems. It is a really important step. Now let's talk about population. So just to recall, set of genes is a chromosome and set of chromosome is a population. Trial and error decides the optimal population size. Premature convergence occurs if there is no diversity. Population initialization types are mostly random and heuristic. Population management models. So there are 3 population management models: generational model, steady state model, and generational gap. In generational model, offspring replaces the parents and each individual survives for one generation only. So GD equals to 1. We take it as it is. A steady state model, 1 or 2 offsprings are generated per generation, which replaces 1 or 2 members of the population. So we take GG equals to 1 over population size. Generational gap is a proportional of the population replaced. Selection mechanism or a fitness based competition. Selection operators are representation independent, and selection pressure is measure of how likely the fitness solution survivor or be chosen as a parent. High selection pressure results in exploration of fitter individuals and low results in exploration of individuals. Balance is really important for the population to reach the goal optimum, and the goal should be optimum. Selection can occur in 2 places: parent selection and survivor selection. Parent selection is the selection from current generation to take part in mating, and survivor selection from parents plus offsprings to go into the next generation. So the very important step is parent selection mechanism. Fitness proportionate selection. Selection probability is proportionate to fitness. Scaling method used are windowing and sigma scaling. Problem with FPS includes premature convergence and loss of selection pressure at the end of runs, which can be fixed by scaling. So there are few very famous process or the methods of parent selection. So first talk about roulette wheel selection. One individual is selected by spinning the wheel, and stochastic universal sampling. Multiple individuals are selected by making one spin of the wheel with several equally spaced arms. Rank based selection. Selection probabilities are based on relative rather than absolute fitness, which reduces problems of FPS. Selection is based on rank, which is assigned based on fitness. The time for sorting algorithm is less than the fitness evaluation time. Sample mating pool by selection probability distribution. So there are linear ranking, and exponential ranking. In linear ranking, it is limited in selection process. Linear ranking is limited in selection pressure, and exponential ranking can allocate more than 2 copies of fittest individuals. In tournament selection, a random number of individuals are selected, and best of these is chosen as a parent. It can work really well with negative fitness value. this uses local fitness information rather than the global information. For example, evolving game players. So whoever has the highest fitness value will be selected for the next round. So here you can see fitness values and the chromosomes and how the random sample is selected and from where a best parent is selected. So there is one more very important or very famous technique of parent selection, uniform random selection, but it is usually avoided because of few cons. Parents are selected by uniform random distribution whenever an operator needs one or some. It is unbiased and every individual has the same probability. Hence, this is usually avoided. Now we will talk about variation operators and my group member will tell you about it.
After the parents are selected using one of the selection mechanisms, they are combined for production of offspring. In this step of variation operators, the parents are recombined and mutated. Recombination is the crossover of parents using their genetic material, and mutation is the random variation to the offspring. One or both of these operators are applied in this step. First, let us look at the different types of crossovers. One point crossover is is a crossover where a random crossover point is selected and the rightmost segment of parent genes are swapped. Multi-point crossover is same as above, except that more than one point like 2 or 3 are selected and alternate segments are swapped. Uniform crossover is a crossover where each gene is randomly chosen from the parents with the flip of a coin. If the if the parent representation is integer, then we have a method called whole arithmetic recombination. This takes the weighted average of the two parents. Like if the two parents are x and y, then the child one would be ax plus 1 minus a into y, and child 2 will be 1 minus a into x plus ay. Next, we let us see about Davis order crossover. Here, the offsprings are generated by creating two random crossover points on parents, copying the middle segment from first and the remaining from the second point of second. And the second child is formed by repeating the same process as mentioned just now. Some other recombination methods are shuffle crossover, ring crossover, partially mapped crossover, order based crossover, etc. Next, now let us discuss about the mutation operators, which is in the same component as variation operators. This is, as we know, it is the random variation to the offspring. So here, as with crossover, mutation is also problem specific. One or more combination of below methods is used. Some of the examples of mutations are bit flip mutation, random resetting, swap mutation, scramble mutation, and inversion mutation. The next component is the survivor selection mechanism. This is nothing but the replacement of the parents with the children. So, the function of this step is the replacement of the population. There are many ways to do this, like age based, fitness based, round robin, etc. In age based selection, fitness is not considered and implemented as delete random or as first in, first out, that is, delete oldest. Delete random method is not recommended as uh, as the population with highest fitness is not considered in this case. Neither the age is considered. So the next one we'll discuss is fitness based replacement. We have two types of fitness based replacements: elitism and genital. In elitism, it is always kept at least one copy of the fittest in solution so far. This way, the fitness of the population is maintained. In genitor or the delete worst, rapid takeover is used with large populations or no duplicates policy. Some other survival selection methods from evolutionary programming is round robin tournament, and another survival selection method from evolutionary strategies is pew mu lambda selection. So this is the best candidates. In this, the best candidates can be lost. Mu plus lambda selection is an elitist strategy. Next, let us consider the diversity of the population and what it is. So, the diversity is very important because because genetic algorithms have to deal with multimodal problems. That is, those having more than one local optimal solution. We might often need to find several peaks, and suboptimum can be more attractive solution. So, hence, the preserving diversity is very important. The approaches to preserve diversity are two types. One is implicit and the other is explicit. Implicit method imposes an equivalent of geographical separation or speciation. Approaches, uh, the example of implicit approach are automatic speciation and island model parallel EA. The next one is explicit method. Here, we make similar individuals compete for resources or with each other. And the examples of explicit method are fitness sharing and crowding. Next, let us discuss about the island model parallel evolutionary algorithms, which is an implicit approach for preserving diversity. In island model EA, there is a periodic migration of individual solutions between populations. Multiple populations are run in parallel. This is inspired by parallel or clustered systems. In a island model, fixed number of generations called epoch are run simultaneously, and after each epoch, individuals are exchanged with neighbors. This is repeated until the ending criteria is met. Here is the model depiction. Here we can see that there is a geographical separation between the evolutionary algorithms, and a periodic migration of individual solutions is happening between populations. Here, ea each ea is an epoch, that is a group of a number of generations of evolutionary algorithms. Thanks for watching.